Notes on similarity. So in these, we're going to use some of our theorems that we've previously talked about before. But our triangles, they're not going to be exactly congruent, but they are going to be similar. Basically what that means is that they have been increased or decreased in size. So if we look at our first one here, or our first definition, so two polygons are similar if corresponding angles are congruent and corresponding sides are proportional. So the angles do have to be the same. Angles are not going to change. They're going to be exactly the same measure in degrees, but the sides are going to be proportional. That means they're going to end up being like the same fraction. So that means the sides, like the smaller one to the bigger one, that means all sides would have been multiplied by 2 or multiplied by 5 or multiplied by 1.5. So when writing a similarity statement, make sure the corresponding parts match up. So we have talked about this. So notice, for example, if you look here, A and D, they both have this, one mark through it. So A is first, D is first. Then, when we get to angle B here and angle E, they have 2 marks through it. And B and E are both listed second. And then when you see angle C, they both have 3 marks through it. Those are the same measure. So C and F are both listed last. So they would have to match up. So if it's ABC, you have to say DEF. If you said DFE, that would be wrong. So you can't change up the order. Okay, so write a similarity statement for the figures. So for the first one here, it doesn't matter the order that we name our first shape. But what does matter is like you do go in a rotation, like in a circular pattern. So like if you start with A, like if we start with A and you go one direction, it doesn't matter which direction you go, but if you go from A to B, you can't jump around. So if you go A to B, C, D, E. So if we said A, B, C, D, E, then we have to start, so we say similar, that's our symbol for similar. We have to start with V and we have to go the same direction. So we would say V, W, X, Y, Z. So V, W, X, Y, Z for those shapes. Okay, so for B, if I start with angle A, notice it has 1 through it over here, then I would have to say D first because it also has, the 1 angle symbol through it, okay? So then if I go to B next, I would have to go to E next because it's got the 2 marks through it. So if I put B here, I have to put E here, and then of course that leaves C and F both last. Those correspond to each other. Okay, so circle the answer choice that is not true. So we're given triangle ABC is congruent to XYZ. Okay, so our first choice is angle B is similar to angle Y. So B and Y, they are both in the middle. So we know that one is true. So AC is similar to XZ. So A and C, X and Z. So first and last, first and last. So we know that one's true. Okay, so I'm going to erase this as we look at our last 2 here. B and C, that's the last, and then X and Y. So notice we've got last 2 letters and first 2 letters. So this is probably it, but let's check our last one. And then angle C and then angle Z, both are last. So that one is true. So this one is the one that's not true. Okay, looking at B. So notice these have been turned on their sides. So if we want, we could rotate it over if we needed to. But we know, like, for example, like if I just rotated that, obviously this would be the angle. Let me change colors here. This would be the angle that's 103. This would be the angle that's 77. So if I wanted to write it out to help me a little bit here, if I said J, K, L, M is similar. So I know angle J is similar to Q. K is going to be the same as N. Oops. JKLMQ, sorry, N there. That should be an N. So Q, N, and then this is going to be O, and this is going to be P, because P and N are both 77. So writing them out like that, because then what you can do is you can look at your letters. So JK and QN. So JK, QN are both first. So that one is correct. Angle M and angle P, last and last. So we're okay there. ML and PO. Okay, so ML, PO. So, and that's both, you know, kind of the bottom of the shape. So angle L and angle Q. So notice here is angle L, here is angle Q. One's third and one's first. So that would be the one that's incorrect. Okay, for example 3, give a similarity statement using the figure and give the value of X. So these are drawn the same direction, which makes it easy for us. So if I just start here at angle A, and if I go in the direction, if I'm going to go this direction, A, B, C, D is similar. And then I'm going to start here at E, and I have to go the same direction as well. So E, F, G, H. E, F, G, H. Okay? And then if I'm going to find angle X, remember angles have to be the same. So X here is in the same place as 75. So X is going to be 75 degrees. Okay. Now to determine if our figures are similar. So if they're similar, then what we check for is similar proportions. Okay. So it helps if you turn your triangles around or like compare, like these appear to be right triangles. We don't know for sure, but what I can look at here is I know that I can compare these two sides for sure. So I'm going to set up a proportion. 20 is to 35. And if I were to flip this top triangle around, I can use like the 12 and the 21. So 12 over 21. Okay. And so now what I can do is I just want to see if these are similar proportions. So to check that, you cross multiply. So 20 times 21 is going to give me 420. And 12 times 35 is also going to give me 420. And since these are equal, then we would say yes, they are similar. So what you want to do is you want to set up similar proportion, or you want to set up proportions, cross multiply. If they're equal, then they're similar. If they're not equal, they are not similar. Now, on B, you got to compare sides of where you have both of the numbers. So like, for example, we've got 10 and 5. So we can do 10 over 5. And then we have both of the bottoms. And since I put 10 on top, I have to put 14 on top. So whatever triangle you list first, that side, like if you put that side on top, you got to do the same for the other side. So 14 over 7. Okay? So since this triangle, since I put the 10 on top, the 14 has to go on top as well. So 10 times 7 is 70. And I need to check 14 times 5 and make sure that it is also 70. And it is. So that works. So this one is a yes. They are proportional. Okay. So for this one, now notice these are isosceles triangles. So you don't want to do these two sides together because obviously that's going to be the same. Okay. So you want to check a side and a bottom to make sure that they are proportional. Okay. So we're going to check 20 over 3 over 4. And then we are going to check 5 over 3. So if I cross multiply, 20 over 3 times 3 is going to give me 20. 5 times 4 is also going to give me 20. Oops. So this is going to be a yes. Okay, so this one, since it gives me angles, what I can check here, both of these angles here, it tells me both of these angles are 100. So what I can do is I can do 360 minus 200 because I have 100 here, 100 here, that gives me 200. So 360 minus 200 is going to give me 160. Now, each of these angles here, total together, and we know that these angles are the same, they have to be together 160 degrees. So now I need to divide this by 2. So that means that this angle is 80, this angle is 80. Well, no angle is 95 degrees. Remember, in similar shapes, you have to have the same angles. So this one is a no. We have to check our angles in this one. All right, E is a little bit tricky. You got to be careful on E because what we're doing, we're comparing this little triangle to the big triangle. Okay? So the big triangle, the side here is 8 and the bottom is 8. So you got to be careful about how you set up your fractions. So the side of the big triangle is 8. The side of the little triangle is 3. The bottom of the big triangle is 8. The bottom of the little triangle is 3. Now, obviously, these are the same fractions. And so when we cross multiply, we're going to get 24 on both sides. So this one, of course, is going to be a yes. Okay, so we're going to find the values of the variable. And so kind of what we have to do here is we have to turn our shapes around and find like corresponding sides and make sure that you're matching up the appropriate sides. So if we know that what our angles are, so this right here, this is an angle. So let's find our angles first, okay? So if this is 90 degrees, remember a 4-sided shape is 360 degrees. So to get this angle, I'm going to do 360 minus 90 minus 65 minus 125 to get what that angle is. Okay, so 360 minus 90 minus 65 minus 125. So this angle here is going to be 80 degrees. Okay, so now what I can do is I can go and I can fill in on my other side what all of these angles are. Okay, so this, and actually I didn't even have to do that. If this was 80, this was my 125 degrees, this was my 65 degrees. So in order to find x, I can do 5x plus 10 equals 65. So if I subtract 10, 5x is going to be 55. Divide by 5, x is going to be 11. Okay? Now, my next part here is I know this side and this side correspond to each other. Okay, to find our y, these two sides correspond to each other, but you have to be careful because they're not equal to each other. So the 2y plus 3, remember, it is shorter than that side. So you got to be super careful here. So what we do is we got to set up a proportion. So I'm going to do 10 to 6 equals 15 to 2y plus 3. And now we're going to cross multiply. So when I cross multiply, I have 10 times 2y plus 3 equals 6 times 15. Okay, so now I'm going to simplify. I'll get 20y plus 30, and 6 times 15 is going to be 90. if I subtract 30, I'll get 20y equals 60. And see, let's go up here. So I've got 20y equals 60. So if I divide by 20, y is going to be 3. Okay, so moving on to the next triangle. So remember, angles are equal. So I'm going to do that one first. So I've got 30 equals 15 plus 3y. I'll subtract 15, and I'll get 15 equals 3y. We'll divide by 3, and we'll get 5 equals y. Now, same thing for sides, just like in that last one. You have to be careful. We can't, these are the sides that correspond to each other, but we can't set them equal. You have to set up a proportion. Now, you have all three sides, so you can just pick any side that you want to use. We definitely have to do 6 over 4x plus 1. You definitely have to do that. And then you can either pick the 10 and the 15 or the 8 and the 12. It doesn't matter. So let's do the 8 and the 12. Okay? So if we do the 6 and the 12, that's going to give us 72. And then we have 8 times 4x plus 1. So I need to distribute. So I've got 72 over here. 8 times 4 is 32. And then there's my x plus 8. If I subtract 8, so 72 minus 8 is going to give me 64. So I have 64 equals 32x. I'll divide by 32. And we're going to get 2 for x. Okay. So this one, we don't want any angles. And notice if you set up a proportion, we don't have enough information to set up a proportion because this side and this side both have variables. So if you tried to set up a proportion, you would have y over 2x equals 5 over 8. And you have 2 unknown variables, which isn't going to work because you can't solve an equation when you have 2 unknown variables. So this is a special case here. So what we have to do, this triangle we can solve. So this triangle here, we can solve for x by doing Pythagorean theorem. So I'm going to pretend I don't know this at all right now. I'm just going to call this a for right now. So I'm going to do a squared plus 8 squared equals 10 squared. Okay? So in my calculator, I'm going to type in 10 squared minus 8 squared because I'm just subtracting this 8 squared. So a squared equals 36. And then I need to take the square root of both sides. So a is 6. Okay? So what this means is, so I'm going to erase where I marked this out. This whole side is 6. So 2x equals 6, which means if I divide by 2, x is going to be 3. Now I can set up a proportion, but now be careful when you set up a proportion because we're using the 6. So I know 6 over y is going to be 8 over 5. So 6 times 5 is 30, and then I get 8y. So I have to divide by 8. And so 30 divided by 8 is 3.75. Okay, D is very, very similar. Very, very similar setup because once again, you have an unknown variable here and an unknown variable here. So what we want to do is we want to do Pythagorean theorem for this triangle. Pretend you don't know that at all. Once again, we'll just call it, since it's hypotenuse, let's call it C. So we'll do 12 squared plus 9 squared equals C squared for right now. So 12 squared plus 9 squared is 225 equals C squared. Then we got to take the square root, and we get 15 equals C. Okay? So this whole side is 15. Now, if we're going to solve for x, we need to do 3x plus 3 equals 15. I'm going to subtract 3. I'll get 3x equals 12. Divide by 3, so x is going to be 4. Now I can set up a proportion. 12 is my leg, y is my leg, and then 15 is my hypotenuse, and 5 is my hypotenuse. So when I cross multiply, 12 times 5 is 60, and then I have 15y. Divide by 15. And 60 divided by 15 is 4. So in this case, both of my answers are 4.